Okay, on intervals where a function is increasing, it's going to have positive tangent line slopes, like on the left-hand side over here. When those tangent line slopes are positive, that means the first derivative is positive. But when it changes and goes to decreasing, that's when the first derivative becomes negative. So if we get a change from increasing to decreasing, our first derivative changes signs from positive to negative, we're going to get a maximum on the original function. Now the opposite is true on an example like this. On the left-hand side, our slopes are negative, the first derivative is negative, and on the right-hand side, it's positive because it's increasing. In those cases, we're going to get a minimum. Now if it doesn't change, if we go from increasing to increasing, we don't get a maximum or minimum. Same is true if you go from decreasing to decreasing on both sides, no maximum or minimum there. All right, so this brings up the first derivative test for extremes. Basically how you do this is you take the first derivative, you figure out when it's either equal to 0 or undefined. We call those critical values or critical numbers. Then we set those on a number line and test whether the sign changes of the first derivative. So let's jump into an example. We already did some of this and found critical points. All right, we took the first derivative of f of x, we factored it, and we found our critical numbers were going to be at x equals 1 and x equals 3. All right, if we're plugging in a 1 here, you get a 0. Plugging in a 3 here, you get a 0 as well. We even made them into critical points by plugging these back into the original function. So we said f of 1 turned out equaling 6 and f of 3 turned out equaling 2. Next, what we're going to do is we're going to place those critical numbers on a number line, in number line order. That's what I've done over here on the right-hand side with the 1 and the 3. From here, what we want to do is we want to evaluate back into the first derivative and figure out one number for each section of this number line. When we plug it back in, is it going to be positive or negative? And that's really all we care about, is positive or negative. So for 0, which is to the left of 1, if we plug it into the expanded version, this term becomes 0, minus this term becomes 0, plus 9. So 0 minus 0 plus 9 makes positive overall in this section. All right, let's do the same thing with 2. All right, with 2, I'm going to use the factored version. All right, so we have 3, we have 2 minus 1, and we have 2 minus 3. Now remember, I care about positive and negative. Positive 3, 2 minus 1 is positive, 2 minus 3 is negative. They're all being multiplied together, so 2 positives and a negative overall makes a negative. All right, and finally, let's do the same thing with 4. We have 3, and then 4 minus 1, and 4 minus 3. Back into the first derivative. So positive, 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 bunch of positives multiplied together to make a positive result. Okay, so what's happening on this graph? Well, on this graph, you could say we're increasing to the left of 1, right? It's positive. We're decreasing, and then we're increasing again to the right. So let's try to classify these critical points as maximums or minimums. So on the left-hand side, if we increase until we get to 1, and then we decrease after that, that's going to make this critical point 1, 6 a maximum. Now, if we do the opposite, if we go from decreasing on the left side to increasing on the right side, that's going to make 3 be where we get a minimum. All right, so this other critical point, 3, 2, is going to be where we have a minimum on our graph. Hope this helps out as we're trying to grasp some understanding about the first derivative test. It's really not that bad, but take your time. Make sure to set up the number line. Good luck.